All right, sorry about that little interruption there. I had to go teach a class, and so I couldn't get the entire video in one sitting. So we are going to continue on with assignment 5B, which is the mean value theorem. So let me just start this question over here. Okay, again, when everything goes right, when it's continuous and differentiable on the interval, it's all good. And then the mean value theorem states the derivative, the instantaneous rate of change is equal to the average rate of change, which is like the slope. So I see that this is continuous and differentiable, and so what I'm going to do is I'm going to set up that average rate of change in this situation, f of 1 minus f of negative 2 all over 1 minus negative 2. And so f of 1, this is pretty easy, it's x squared, so that's 1 minus negative 2. It's going to be positive 4 all over 3, and so this is negative 1. Okay, so we have the average rate of change. Okay. Next comes the instantaneous rate of change, which is the derivative. So the derivative is 2x. So I have all the pieces. Now I can just go ahead and use the mean value theorem. So that says the instantaneous rate of change is equal to the average rate of change. And so the c value that would take place is negative 1/2. Notice how it's on the interval from negative 2 to 1. That is that c value that is somewhere in between a and b. I know I have it written as an x, but it's the c value. Okay, so again, this next one is continuous differentiable. So the average rate of change in this situation is f of 1 minus f of negative 1 all over 1 minus negative 1. So 1 is x to the third plus 2x is 3. Negative 1 is negative 3, so this is 6 over 2, so this is going to be 3. Okay, that's the average rate of change. I need to find the instantaneous rate of change. So the instantaneous rate of change is the derivative. That's going to be 3x squared plus 2. Now I can go ahead and use the mean value theorem, which says that the instantaneous rate of change is equal to the average rate of change. The tangent is equal to the secant, as far as slopes are concerned. So the average rate of change was 3. My instantaneous rate of change is 3x squared plus 2. So this is what? X squared is equal to 1/3. Thus, x is equal to plus or minus square root of 1/3, which is the same thing as saying plus or minus root 3 over 3. Both of them are in the interval, so negative 1 to 1. Both of those are in the interval of negative 1 to 1. So sometimes when I get these things, sometimes, you keep the positive answer, you keep the negative answer, because that's the only thing in the interval described. However, this interval has both of them, so you keep both. Okay, this one is not, well, it might be differentiable. Yeah, I think this one's good to go. On 0 to 1, I think it's fine. So the average rate of change is f of 1 minus f of 0 over 1 minus 0. So 1 is going to be 1, 0 is going to be 0 over 1, so this is 1. Okay, instantaneous rate of change is the derivative. And so notice how x cannot be equal to the number 0. That's fine because this only has to be differentiable from 0 to 1, like curvy bracket 0. So it can't be 0. That's fine. So it's differentiable where it needs to be differentiable. So this one's fine. So this is continuous and differentiable where it needs to be. Mean value theorem. I'm just going to take a look at the graph of this real quick. This is not differentiable on -1 to 3. You'll notice that if this is -1, this is +1. It has an intercept at -1/2 with a slope of 2, I think. And so if this needs to be differentiable from -1 to 3, it's continuous, all right, but it's not differentiable. Open brackets, -1 to 3. So again, it has to play by the rules. It has to be continuous on -1 to 3, which it is. This one's continuous, all right? But it's not differentiable on open, -1 to 3. So you can't use the mean value theorem in this situation. You got to use something else. All right, next we are on problem number 45. Okay, so problem 45, continuous differentiable, yeah, sign and everything, it's all good. All right, so the the average rate of change is f of pi minus f of 0 all over pi minus 0. I don't know about you, but I need a circle to kind of help me out here. So the first one is going to be sine at pi, and the sine is 0. minus f of 0, again, that sign is 0, and the sign, again, is 0, all over pi minus 0, this is equal to 0. Okay, the instantaneous rate of change is the derivative. Cosine x. So we got killer sign down there. And then we have the mean value theorem, which says the instantaneous rate of change is equal to the average rate of change. The tangent is equal to the secant as far as slopes are concerned. So that means where the heck is cosine equal to 0? Again, so let's break out our thing here. And so cosine is the x coordinate. And so where is the x coordinate 0? Well, it's right here and right here. So it would be like pi over 2, 3 pi over 2, 3, 4, 5 pi over 2, like if you make more than a circle, you know, et cetera, et cetera, et cetera. 7 pi over 2, things like that. However, take a look at the interval in which this applies. So obviously this 5 pi over 2 doesn't make sense, nor does actually the 3 pi over 2. That's not in the realm that we're looking for. So this one only has an exclusive answer of pi over 2. But if like this question was, hey, what is the answer from 0 to 2 pi? Then everything would have been the same thing, pretty much. Same answer, except you would have an answer pi over 2 and 3 pi over 2. Okay, so in these sketch a graph of just a rando function, anything you want, that gives the condition but does not satisfy the conditions of the mean value theorem. So again, mean value theorem, like the punchline is this: it has to be continuous and it has to be differentiable. Okay, here they want it continuous, and so where the wheels need to fall off this thing is we need it to be continuous, but thus we don't want it to be differentiable. And so all we have to do is draw a picture that is continuous but not differentiable from -5 to 5. So, bam, there you go. It's continuous but not differentiable. Consider the function which of the statements is false. Okay, is false. Okay, let's see here. Okay, so what this is so the picture from 0 to 1 is 1 minus x. So it doesn't have this, but it's 1 minus x from 0 to 1, and then this is equal to 0 at 0. That's what this picture is. Okay, is it differentiable from 0 to 1? Yeah, it's a straight line. F of 0 is equal to f of 1. Yeah, f of 0 is 0, f of 1 is 0. That one's correct. It's continuous on 0 to 1. No, it's not continuous. Look at this. There's a hole. No. The derivative of f is never equal to 0 on 0. No, because it's all equal to, the derivative is all equal to -1. So yeah, it's never equal to 0. So that would be technically true. Okay, yeah, C. was the last question, right? Okay, mean value theorem on the interval 0 to C must be, okay. Average rate of change on 0 to 2 is f of 2 minus f of 0, 2 minus 0, 2. Zero minus 0, which is 0, over 2 is 0. Okay, so this could be Rolle's theorem, technically. This could be Rolle's theorem. When the slope is, when the average rate of change is 0, you can use Rolle's theorem. Okay, so the instantaneous rate of change is the derivative. And so that's 3x squared minus 4. So thus the mean value theorem is instantaneous is equal to the average. Tangent is equal to the secant. So 3x squared minus 4 is equal to 0. So this would be plus 4 divided by 3. X is equal to plus or minus the square root of 4/3. But since it's on the interval from 0 to 2, the negative portion of that doesn't make any sense. So the positive version is the only thing that you want, and that is that answer. Okay, so what is that answer? So this is the same thing as saying, what, square root 4 over square root 3, and then that would be 2 root 3 over 3. All right, going from -1 to 1. Let's see here. Yeah, that's good to go. I don't see any. Oh, wait, hold up. Wah, wah. This is not differentiable on -1 to 1 right here. This is not differentiable on -1 to 1. Okay. Thank you for watching the second part of the video. Yeah. Have a good one.